Good evening, and this is the last panel. Unfortunately, we do not have two panelists with us, but anyhow, we'll proceed. So this is the panel on engineering and deep tech. I'm not an engineering student, so allow me some of, loopholes in some of the questions. You are experts there. I'll start with Professor Annapurni Subramaniam, uh, Director, Institute of Astrophysics. I've interviewed her on previous occasions too. But ma'am, please provide us insights into what specifically deep tech means and what scope does it open up for industry. And now we are talking about Industry 5.0, if you can provide insights.
Yeah, so this panel is regarding technical and technology and what we can do to the education to, the younger generation also to catch up and go to the future in this direction. So I come from the background of astrophysics, but we do, observe the sky. It's basically a pure science. But then astronomy, as you know, is driven by engineering. Because if you don't have big telescopes or space telescopes, space programs, we are not advancing science. So in general, what we see is astrophysics and astronomy has demanded the technology to go to directions which have not otherwise asked. Like for instance, GPS. The directions are given by quasars up in the sky. Second, the cameras you have in the mobile phones, that's driven by requirement of low light sensitivity, etc. And we also have requirements for space programs, which we gives other things of knowledge about things. So this of taking you to technology which you otherwise don't demand, which require fineness, which require precision, which requires advanced manufacturing. So that is where we are looking at deep tech, where technology, otherwise, there are consumption, you consume technology. Like the previous panel discussion, we were seeing how you adopt AI into your curriculum. Can you drive the AI? You can ask the question, right? Can you make different algorithms which can be much more efficient? Can you drive the next generation AI from your country? Can you drive the next generation of manufacturing within here, efficient manufacturing? Can you have different protocols or different methods? So there you need to have fundamental understanding of maths and physics. It boils down to that. So STEM education is extremely important and solid foundation, which also gives you to make you flexible to adapt to the situations where you need to immediately create certain technology which is required for different purposes. So this is the foundation we need to provide, and manufacturing as well as capability within the country rather than having only an assembly unit. Can you actually create things here? So this is what the deep tech is about. Of course, it requires investment, infrastructure investment, and a lot of R&D investment involved. But unless we start it, we will not be able to drive the technology for the future from the country.
Thank you. Professor Acharya, coming to you, would you say that that kind of academic infrastructure exists in the country, the kind of curriculum changes that are happening, and also is there good, healthy industry academic exchange to facilitate that kind of deep tech?
So good evening. Thank you so much for having me here. Probably, odd man out in this forum. I am not a hardcore academician. I came from almost 22 years in the industry. Now, instead of being on the side of a problem, I wanted to be on the side of a solution. So I made a conscious switch from 22 years of industry life, led a very high-tech life, and then moved into academic. So I think I will be able to answer that question from both sides of the world, where what industry is facing, what the academia is facing. I'll just take one more minute to give a little bit of context. Just a few days back, I was addressing about 100 principals from different schools. There, we were actually trying to debate where is the problem. If you see the whole chain of education, everyone is complaining that the input they get is not ready. If you go to higher schools, they say the primary education is a problem. If you go to the pre-university, they say school education is a problem. If you go to a higher education institution, they say pre-university is a problem. If you go to an industry, they say higher education is a problem. Finally, if you go to a customer, they say industry product is a problem. So there is a disconnect across from schools to primary schools to the pre-university to education to product. So somebody needs to put this as a sutradhar. Somebody has to connect all of this. If Muhammad cannot go to the mountain, mountain has to come to the Muhammad. That connectivity, unfortunately, in India, I have not seen many of the people from the industry directly getting embedded into the education system. At least a few of us are trying. Let us hope we'll be able to make some difference. Now, coming to a question on whether the education system is geared up for that kind of a transition or not, I heard from the previous panelist, industry academia collaborations are happening compared to what it was 20 years back. Now, a lot of things are happening. The other day, there was a company, a robotics and AI company approached us saying that I don't get talent in the AI space. I don't get people from the robotics and AI space, etc. I said, you don't get, so what are you doing? So we said, why don't you come and sit inside the university, work with us, develop it, and work within the university. So as we speak, we have now a robotics and AI company within the campus. They have set up their R&D in the campus. They co-design, co-teach with us, and the internship is done in the campus. This is the only way. If you see many of the Western worlds, industries have set up their R&D centers, industries have set up their functional activities within the universities. That is the way they're able to bring up the chain. Right, I'll stop here. I'll come back later on. Thank you.
Thank you. So, Professor Subramaniam had mentioned about the kind of manufacturing that is needed. And in the last few years, during some of the visits to various IITs, I've seen how, the kind of work that is happening on 3D manufacturing. Then at IIT Madras, there's this whole incubation and innovation ecosystem. So a lot is happening on various new age disciplines, but I would like to change track here. So, typically with so much of, emphasis on AI, ML, data science, new age disciplines, what future do you see for traditional engineering streams? And, one gets the sense that, some of these are losing popularity among students who are joining, and some of the institutes have also shut down their, offerings in civil, mechanical. Do you think that the need for these disciplines does not exist because one can't, on the face of it, think of engineering without civil or mechanical? Sorry, what do you have to say about that?
Not at all. In fact, it's a wrong notion. What has happened in learning, teaching learning, is there's been this phase of interdisciplinary understanding, teaching and learning. Then it went to multidisciplinary. Then today we talk about transdisciplinarity. Specifically asking your questions with respect to, this is a topic on engineering. So I suppose you're referring to circuit branches, mother branches like civil, mechanical, electronics, electrical. There has been a tilt shift in the way in which these core branches have transformed themselves. They have transformed by embedding technology into them. A simple example, computer science, mechanical equals many things. One of it is robotics. You have biology or biotechnology mixing with electronics, and then you have biosensors, bioinformatics. Now, these are fields that are emerging, but there are jobs also plentiful in that. So an amalgamation of core as well as technology gives rise to a domain that is in high demand. Now, to take a step further, what are we as institutes doing? We should adapt. And I think in the title truly says future-proofing. This is future-proofing. Now, as Doctor said, fundamentals, math, physics, they are fundamentals. You cannot let go of that. Based on that, you build models, etc. Now, if we truly want to transform and have civil engineers who can use artificial intelligence, of course, combined with data science, data analytics, quantum computing to compute the data, you will have an engineer who's well versed with smart city as an example. How do you create a smart city concept given the space, area, and many other constraints and domains? So, to answer your question, they are not dying. It is in fact getting adopted. And what is the core ingredient there? It is technology, giving rise to multiple opportunities.
Coming to you, Mr. Chitnis. So, what is your thought on that, and how to make students interested in these core disciplines? And as Mr. Chebbi said, that interdisciplinary approach is the answer. What would you say about that?
Yeah, actually, students are already interested, right? When we give them exams, which are theory exams, or teach them in classroom, that's what actually reduces their interest, right? So, why I'm saying they're already interested, as a child, also people are curious, right? How things around them are working. If you see this room, everything is engineered here, right? There are very few, except for human beings here, maybe a few insects, I don't know. Everything is engineered, right? And people are curious how it works, right? When there are drones, we have seen movies, right? 3 Idiots, etc. Students get interested to build those things, whether it's drones, robots, those kind of activities, right? And these are all interdisciplinary. Right? Drones requires not only aerospace, it requires, if it is command and control, requires mathematics, computer science, control theory, everything, electronics. So the whole idea is that instead of killing their interest, we should help them to build the curiosity, innovation, problem-solving ability, give them facilities and support, whatever is required. They will grow on their own, right? So whenever you see student project exhibitions, right, it's not that somebody has kind of pushed them towards interest. All of them are actually interested and really putting nights outs and a lot of effort there to bring those projects up. Thank you.
Coming to you, sorry. Sure, you may.
See, the core engineering is not going to die. It is going to remain, as sir rightly said, we have to build ships, we have to build airplanes, we have to build cars, we have to build so many infrastructure. I came from L&T background. There was a task which was given to me to hire 500 mechanical engineers, good mechanical engineers in the country. I'm not talking about a state. We went from college to college to college. They were good students, but they were so disconnected from what is needed by the industry in the mechanical engineering, core mechanical engineering. We were really surprised. So it's not that the jobs are not there. In every sector of core engineering, there are jobs. Take electric vehicle technology, for example, we were looking at about 500 to 600 power electronics engineers. We could not get, even in IITs and NITs, I could not get. So jobs are there. It's only the disconnect of what is needed at that level that is missing piece. And we have unnecessarily, I'm not saying this out of context, but it's real with context. We have invested a lot in training people on computer science, and AI has been extraordinarily educated. And we have created that industry. But the gap is more not in the IT sector, it is more in the core engineering. So if the institutions and industries really need to come together to fill that gap, IT will pick up. They have built up their own education. They lived through the IT sector also. If that gap can be built, then I think enough of jobs are there. Many global capability centers which are setting up here, they are setting up it in core engineering, but they're not getting the talent. That is where the gap is.
Till a few years ago, at least, because based on several visits to engineering colleges and even ITIs, the notion was that, typically engineers after passing out, they go for MBA degree. And the actual function of civil mechanical is done by students who go through ITI education. Would you say that practice still holds today? Yes.
Not quite. A large chunk of, I'll give you a context. I'll give you a story. This was my interaction with a bunch of engineers who have, in fact, who build plants, automated plants for Tata Motors for their assembly line. And their take was, we find a lot of students leaving our organization, and those students are BTech students. But the ones who stay with us are the ones who have done their ITI, who have done their diplomas. Why so? They know hands-on they have a hands-on experience. They stay loyal to it. Their CTC is pretty at a certain cap. Companies can afford it. We have loyalty in them, so on and so forth. But where do you get engineers with core knowledge? Where do you get engineers with knowledge of technology who upgrade themselves? Where do you get individuals, students who become graduates and then employed with higher order skills, such as critical thinking, creativity, and all of those things? They do generally, and I'm not stereotypizing it, generally come where there is a 4-year full-time engineering degree. And of course, the college and their academics and their interests matter. So yes and no.
Coming to you, Professor Subramaniam. So Professor Chitnis had mentioned about the need for innovation, and you had also mentioned about the facilities and infrastructure that exists for it. But I remember a few months ago where China had introduced its DeepSeek, and there was such a big commotion across the world that more and more users are shifting to that, and there was this whole debate about why is it not happening in India, and then there was this clamor about Indian institutes do not provide that kind of ecosystem infrastructure, right kind of culture for that kind of innovation to flourish. Would you agree? What are your thoughts on that, and how can we really create that kind of conducive ecosystem and infrastructure for innovation of that level?
Yeah, so I will take this question in a broader scale because this is just regarding AI, but we also have other things like, manufacturing techniques or even one space sector. If you look at how do you expand in the space sector, can you make rockets which can lift off heavy loads? So like SpaceX, can you have things like that in India? So where does it happen? Can it happen in academic institutions? Can it happen in research R&D labs? Or does it happen in industry? It actually has to happen in industry, but with the ecosystem. Because with the experience, how I'm saying is that India is a partner to building an ambitious project called 30-meter telescope. It's a telescope with a collecting area of 30 meter. So you can imagine the aperture, one end to the other end is 30 meter. Now, in general, telescopes have optical surface like glass as a reflecting surface. It's the primary mirror. Now, can you create a glass which has got a 30-meter diameter? Single glass is not possible. So the technology, actually, it's a disruptive technology. You make segments of mirrors, and then you place them together and align it very high precision so that it acts like a single surface. And that technology, we have it now in the country. So we have been partner for that project for the last 10 years. And the last 10 years, we have actually got the technology which is actually existing in the US. Only one lab is actually qualified to make these. We have it in the country. We have a production facility where we can actually make segmented mirrors. L&T has qualified to make support systems. They have 492 mirrors of 1.5 meter size. Will make that particular 30-meter diameter. And you have to have 492 support assemblies, which itself is an assembly of many components. Everything is precision make. So that technology we have in the country now, we are making it. Now, this is an ambitious project that cannot be done in an institution like IIA or in even IIT because it's a production line. The R&D, this has to be done at an industry. But the industry will have to have infrastructure developed to do it. So there has to be, because industry will also have to make some profit or keep the ends meet, right? So you have to have some support from the government to actually involve in it, and there will be always byproducts out of it. So one has to take a step forward and do it. But what actually happened was, no industry came forward to set up the segment polishing facility because there was no direct or immediate application available. So we set it up in our campus. So we have absorbed that. Government, the Department of Science and Technology has absorbed that. In the process, we will actually open it for future, things like future programs and companies to use that for certain purposes. So you have to deal with it and have a consortium, emerge out of it and take it forward. Unless and until this happens, you will never have any cutting edge or completely different technology. It may be AI, because then you have to have, huge servers, huge computer setup, everything to be there for your thing to work. And who will foot the bill? It's not easy. And who will even provide the space and infrastructure? That's not possible. So you have to have an ecosystem. Even if you want to have a SpaceX like venture within India, you need to have a huge support, and there has to be, contracts given to that company to some assurance that you will be getting some contracts so that you can be on the job for a while, right? Instead of die down kind of a thing. So there has to be a lot of hand holding, there has to be a lot of support and ecosystem developed so that we can emerge. But if you do it, it's an extremely good, important investment, which will take us in pole vault to the next level. But if you don't do it, it's a missed opportunity. But this is the case with all the deep tech or, areas you do. And of course, to talk about students who come work with us to make payloads, because we have 2 space payloads up in space and further things that we are doing. So when we get students, they're very ambitious. And we know that they can actually run an extra mile or 10 miles extra to learn from us. And they're willing to do it. We just need some hand holding. So we need to have more ecosystems where people can take up challenging projects and they can execute it. I'm not saying everybody is up to it, but there is a good number of students who are wanting to do that. But we need to create that ecosystem. Otherwise, we will lose the opportunity of larger number of good students who are in India. So that we need to support.
Thank you. Coming to you, sir, again. Some of the developments in the last few weeks when Trump administration had revoked so many international students' visas, and that has impacted Indian students too, including, students who are very keen to go to US universities for engineering. What signal does it give to Indian academia that we need to strengthen our own campuses, our own infrastructure, so that engineering education within India becomes, attractive enough? What would you have to say for that?
Yeah. So first of all, what Trump does is, in my opinion, is purely political. In my opinion, whatever Trump is doing in US, right, is purely political. It may stay, it may go on, but it's a good opportunity for Indian ecosystem, as Madam told. It's not just academic, but the research, everything. Today, I've heard from a lot of startup founders that this is the time to be in India, irrespective of what opportunities are in US, etc., like that, right? Because our economic whole ecosystem is just waking up, right? You recently saw the demonstration in the recent India-Pak skirmishes, right? You might have heard of a lot of defense tech, which has come from India, ground, both public sector as well as private sector, right? And they've done marvelous things, right? So that's what is happening in India in all segments, right? It's not just thing. You are using UPI today, right? So in computer science, there is ONDC, Aadhaar. So what we call as India Stack, now it's called as Citizen Stack, which is being used in, I think, 22 different countries. So we should not worry that just because US is not allowing, we are forced to stay here. Actually, India should be the first choice for everybody to work. And that includes studying and taking up professions, taking up research, everything. Thank you.
Thank you. You preempted my next question, which was about the developments of last few days. And defense experts on several channels were actually congratulating the engineering institutes and engineering experts who developed all those technologies which enabled, safeguarding countries' interests. Would you say, taking on from there, that the narrative will change now in favor of disciplines that help serve the nation rather than disciplines that help in earning big bucks? Professor Acharya.
No, as I said, the mother branches will never die, right? They are the backbone of the country. They need to be encouraged. As educational institutions and as society, we need to realize that the job sector or segment is changing. If you look about 20 years back, the engineers, what kind of jobs that they were doing is now being done by technicians, diploma guys. Now, what some of the ask and the higher level people are doing that now coming to the undergrad students, etc. So the job sector is changing. For example, if you see the title of our presentation is Industry 4.0, Industry 5.0. We are changing from Industry 4.0 to 5.0. What is the fundamental difference? What is the role that the sector can play? Industry 5.0 requires a lot of human intervention. 4.0 is predominantly, we are talking about automation, IoT, AI integration, so on and so forth, keeping the human out of the element. Whereas 5.0 requires a human as part of human-machine interaction and making the intelligent decisions between machine and human. So those, if you have to bring in people, you need people who understand the system, you need people who understand the domain. Without that, the machine itself cannot become 100% intelligent. Now, there is an emerging field, for example, called human factors. If you are going towards an autonomous vehicle, while we are all very proud of level 1, level 2, level 3, level 4 of autonomy of vehicle, if the vehicle can drive on its own, there is a time when the vehicle also has to give back autonomy back to the user. Now, machine cannot determine whether the person who is driving is in a safe method or safe state to take over the control back. Now, this is where the human intelligence comes into picture. This is where the domain knowledge comes into picture. This is where mechanical engineering comes into picture. Today's engineers, they are required to be engineers rather than calling themselves as sectoral, civil, mechanical, electrical, etc. So the base will remain, but on top of that, as Sir said, we have to be highly becoming interdisciplinary and multidisciplinary. That is the only way the world is going to move and sector is going to move.
Mr. Chebbi, would you like to also answer my question about, now is the time to be in India, as Professor Mr. Chitnis also said, and my question about, serving the national interests.
Okay. If I remember your question correctly, would the monies go more towards protecting, serving the nation, or in making making money as things were before? Correct? Is that?
Yeah.
Well, let me put this in an analogy. If a human being has a serious critical health problem, he has only one problem. If he does not, then he has so many problems to deal with. If a nation goes through something of a cross-border terrorism or attack by another country, the whole country comes to a stop and they just focus on ensuring safety, retaliation. So to answer your question, yes, I think India, as many other nations, because of the change in the geopolitical situations, countries becoming more self-reliant, self-dependent, concerned about tariffs, the buzzword that is continuing to stay, countries will invest in safeguarding their interests, be it for a cyber attack that is in technology, be it on borders, and so on and so forth. But business will still remain. Most of the production and consumption might happen within certain favorable countries, but both will go hand in hand. But for sure, there will be a surge in the spend for the country up until a certain time when there is a new normalcy. And to the other question with respect to Trump cutting the funding, I think the universities abroad, Harvard's and the likes of it, are more worried about their endowment being cut as opposed to international students facing certain restrictions. I still see a large surge in number of students going abroad, especially to the US. I don't see there as a challenge. But yes, India as a country, recognizing the large population that it has and the consuming nature of its population, can work a lot on developing educational infrastructure that can help people work with, or at least policies that could help institutes work with industry, and probably, if not fundamental AI as a research topic, but applied AI can be focused on, and which is easier to do because India has mostly been a service nation, and products or core research has always been less. Our spend on R&D is a little more than 0.5% of its GDP. So you can see where Dr. Kalyani is, sorry, Madam is coming from in terms of spend that is required. It doesn't come from government. It doesn't come from industry. It certainly will not come from institutions for not-for-profit. So more impetus has to be given. A thought has to come that we need to focus more on research. So I think I've done all three questions I touched upon a little bit. I hope you don't mind.
So, Professor Subramaniam, since he mentioned about the spending on research being very minuscule, you come from that research background and you have devoted your life to research. What is your experience about research being fostered or being, not being given its due importance?
Yeah, so I have been in the research area for the last 30, 35 years. So the support, I mean, as a quantum has increased, definitely, but then GDP also has grown. So the fraction is actually less now. But most difficult part which is faced by most of the research R&D institutions right now is the certain kind of restrictions on how you spend it, etc. So there's a lot of restrictions. So that puts us on the back footing. So like in my case, even if I get the money for a particular project, I would end up spending more time on navigating these rules rather than, innovating on how effectively I do the project. My innovation is more on the navigation through the rules. So if that can be eased, then more time can be invested in utilizing that funds appropriately. So that many R&D institutions are facing. I believe the government is also looking into ease of doing science. But coming to R&D, the major step which the government has taken is the formation of the ANRF by the Department of Science and Technology. That's a huge leap. And we have seen couple of programs being rolled out by PAIR program is one, where you can actually have a hub and the spoke model, where you invest in an institution and that institution handholds certain universities and etc. in the STEM area for specific goals. So that will eventually uplift the ecosystem and the R&D base of the country. So you need to lift the R&D base so that people can have access to labs where you can try doing an R&D. Coming to innovation, without innovation, you can't survive. So curriculum as well as environment has to be conducive to innovation. You should be able to try something out. You should be, just because nobody has gone that path, I'm going to go through that path, then you never will have innovation. In my area, in the space sector also, failure is the norm. Success comes after the failure, and you normally end up learning a lot more in that failure, because then the next step will be a success, and you will also learn a lot of things in that failure. So you have to have that particular provision. You can't say that always you have to succeed. You can't have a failure. So that is not possible in R&D. But the ecosystem has to absorb that. So it's just going in a good direction, and I believe next few years we will have a better ease of doing science and more funding coming in, and also ANRF brings in industry funding also into it, and funding on a the industry academia funding. So these would happen. Supposed to strengthen the links and also take the prototyping which you can do in the R&D to the industry. So TRL levels of all these technology or products can be increased to the up to the market or wherever you want to deploy it. So we hope things will be better in the next few years with more increased funding and all this networking, better networking within the country. And I think it'll be very useful for the next generation, because we have a lot of bright students and they'll be able to take up and take part in all these kind of opportunities which are coming up here.
So before we close, I'll have one question for you, sir. So we have, over the years, at least in the last 15 years, we have read about reports about engineering students and graduates being very, not being too high on EQ, emotional intelligence, and report after report has cited that. And then the COVID period also came, which also impacted mental well-being of students. what would you say about engineering students as of today?
Yeah, I won't brand everybody in the same bucket, but yes, more or less there is a issue that primarily comes because of these competitive exams which they have to pass. So everybody in the school, they're afraid that no, they have to give JEE, CET, etc. They don't have time to go have sports, travel, talk to their family and friends that much. Of course, they are doing that. And of course, social media also has its own impact, right, in terms of compartmentalizing things. Once they come to university, they do open up. They have a lot of clubs, student activities, and so then their real progress starts once they come to higher education institutions, right? But yes, there also we have exams, etc. But they are kind of manageable. Students are very smart to kind of manage those kind of things. Once they get over that fear of getting into some XYZ kind of thing like that, right? So that's the main thing. But having said that, when we are talking about the era of AI, right? So now this kind of technical edge is kind of will have lesser impact because anybody who has access to ChatGPT, where you yourself can derive a complicated mathematical formula or take help of AI to do the same, right? You are at the same level to solve some genuine problems, provide solutions, etc., right? So in that context, EQ is going to become super important, like that, right? So now is the time for education institutions to give that time and space and nurture EQ in the students of all disciplines, not just engineering. And because that's what is going to help them in their future life. Thank you.
Thank you so much for such an enlightening discussion. Thank you.